Hey guys, welcome back to IT Classroom. I hope you all are doing well. So today we're looking at IGCSE Physics 0625 Paper 4 Variant 2 from Feb March 2024, which undoubtedly is one of the latest papers which also is compatible with the new syllabus for physics. So make sure you do stay till the end of the video to get helpful tips and also explanations for all of the questions throughout this paper. And I hope that this video will be helpful, especially to the May June candidates who are coming up, gearing up for the exams. 1 month to go, guys. So please work hard for your exams, and it's a one-time opportunity. Yeah, and yeah, best of luck to all of you. So let's start with this paper 0625, paper 4. All right. Now the first question is often a speed time graph, as you see here, and it's very common. Make sure to learn this topic, well, you'll most likely expect at least one question from this topic. So it says that describe the motion between 0.90 minutes and 2.9 minutes. So if you see 0.90 minutes is somewhere here starting off, and 2.9 is somewhere here. So here there's a straight line, there's a straight flat line which does not have a gradient, which means this constant speed. All right, you have to write constant speed. Because as you can see, the speed does not change in this period. Then between 2.9, that means from ending from here, and it's going all the way up to 3.5, which is here. Now here you see that there's a deceleration of the car because there's a gradient, and the deceleration is constant. The line is not a curve, it's a straight line, which means constant deceleration. Then from 3.5 minutes to 4.5 minutes, we can see that the speed is 0, which means the car has not moved and it's stationary. All right, moving on. I hope this question is clear. So another bus travels at the same speed of 8.9 meters per second square. So 8.9. The brakes apply a constant force and the bus stops on a distance of 23 meters. The bus had a mass of 18,000 kg. Now it says calculate the kinetic energy. The kinetic energy, simple formula, half mv squared, where only v is being squared, so the mass is 18,000 kgs, and the velocity of the bus is 8.9 squared. So if I calculate that, that gives me 0.5 into 18,000 into 8.9 squared. Yeah, that's 712,890. Which, if you add in two significant figures, it should be 7.0 into 10 raised to, no, I'm gonna write that. I'll just put 7 here. So 7 joules. You can also express it as 710 kilojoules. It's for your preference. So I would prefer this method. Then it says calculate the force applied to stop the bus. Here use the formula that work done is equals to the force in the distance moved. Why? Because work done is basically the energy transferred. So in order to stop the bus, you have to transfer all this kinetic energy into the potential energy of the bus. So if I have this much more of kinetic energy, I'm going to use the same value, which is 712,890. This gives me more accurate answers, and I would recommend you guys that you do the same as well. It is not necessary to write this value, but when you use it, you can always get a better, a more accurate answer. Divided by, now we want to find the force, so the distance is 23 meters, which will give us, if we divide it by 23, that gives me 3995 2 then dot, which can be written as 31,000 newtons, or you can also write it as 31 kilonewtons. I hope this question is clear. It's, guys, 8 marks. So yeah. Moving on, next question is define impulse. Define impulse is a simple thing. You can use the formula that is force into the time which it acts for. Alright. Then figure 2.1 shows a rocket and its exhaust gases. The exhaust gases are emitted from the rocket with a velocity of 1400 meters per second and at a rate of 2800 kg per second. Show that the force exerted on the rocket by the exhaust gases is 3900 kilonewtons. So now if you know that the velocity of it is 1400 meters per second, and we can use the equation that your force is equals to the mass into the acceleration. So the mass of 2800 kg, it has, because both of them are given per second, so we would know that the acceleration is also 1400. So 1400. So basically, when I do that, 2800 into 1400, that gives me 3920000, which can be written as 3900 kilonewtons. If I just remove these three, so I would get 39200 kilonewtons. Calculate the maximum mass that this force can lift from the ground. Ignore air resistance. So I haven't seen a question like this in a while, but here is a simple fact to remember, that if you want to know, if you have been given up the force, and you can use the same formula, F is equals to ma, and we want to put the acceleration as the Earth's or the gravitational force acceleration, which is 9.8 meters per second square. Now why is this? Because if you want to take off from the ground, you want to calculate the maximum mass, so you have to minimum of this, although acceleration can be greater actually. So if you have the equal amounts, or basically even a slightly bit more, you'd be able to get your mass. So F is equals to ma. So if I want to m, then the F would be 3920000 divided by the acceleration of 9.8. I hope you get why I use 9.8 divided by 9.8, which gives me 400,000 kg. That can be written as 4.0 into 10 to the power of 5 kilograms. Do not express in tons, as it's not a appropriate unit, basically a standard unit. So yeah, do not express in tons. Then it says that the next part of the question, which is a car has a weight of 13,000 newtons. The car is supported by 4 tires, which each have an area of 0.016 meters squared. Calculate the pressure on the car due to the weight of the car, pressure on the road. Now, since pressure is equals to, okay, my P is capital. Pressure is equals to force divided by your area. Your pressure will be the force of 13,000 newtons. Be careful here, there are 4 tires. So to multiply 4 into 0.016, because that's the total area of contact. 13,000 divided by 4 into 0.016. That is 200,000. Okay, 203125, which will be 200,000, or 2.0 into 10 to the power of 5. 2.0 into 10 to the power of 5 PA, which stands for pascals. I hope this question is clear. It's a pretty easy question. Now the next part of this, which is I have a bit of confusion here. Yeah, so A should actually, oh my bad, A should actually be capital here. P is equals to F over E, although you can just write it as pressure because the force over area if you're comfortable with that. Then explain in terms of particles. Explain why the air pressure in the car increases when the car travels along the road. So first reason, we would say that when the car travels on the road, the particles move faster, and when the particles move faster, they collide with the walls more frequently, leading to a greater rate of change of momentum, increased force. And moreover, whenever you travel along the road, there's a friction. There's like a friction between the road and the car tires, which means that the work is being done, and if work is being done, that means there will be increase in the temperature. When the temperature increases, the particles move more fastly and collide with the walls more frequently and with more energy. So this is the main idea. You can organize it in your own way. I would say that when traveling along the road, the particles move faster. Particles move faster and collide more frequently. With the walls. leading to greater force on them, greater force on walls, which increasing pressure. The second thing you want to be sure about is basically that also the friction. So this is for 4 marks. It releases hydrogen between road and tires increases your temperature, which causes particles to move faster, particles to gain energy and move faster. And when they move faster, leading to more harder and frequent collisions. Which increases pressure. Next up, this says that, okay, it's a bit long, I'm sorry for that. A gas cylinder contains helium gas at a pressure of 2.0 to the power 6 pascals. A volume of 0.026 meters cube of the compressed gas is sealed from the cylinder into the balloon. Each balloon contains 0.015 meters of helium at atmospheric pressure. The temperature remains constant. Now, calculate the maximum number of balloons that can be filled. First of all, important formula to realize that PV is constant. So now you would need to know that if I bring this pressure 2.0 to this pressure, then what would this volume be? Alright, so first of all, 2.0 into 10 to the power of 6 into 0.026, which is 2.0 into 10 to the power of 6 into 0.026, 52,000. Then your 52,000 divided by 1.0 into 10 to the power of 5, which is 0.52 meter cube. So that would be your volume. Now, if I have 0.52 to fill, and out of that, one balloon uses up 0.015, that would be 34. So 34 balloons. Alright, so I hope this question is clear. Then it says define specific heat capacity. Just remember the formula, which is Q is equals to mass mc delta T. So hence it refers, no, remember I start with it. Specific heat capacity refers to the energy required to raise the mass of 1 kg of substance, you can say unit mass as well, by 1 degree Celsius. Alright, so it says that a volume of 0.0024 meter cube of oil is heated in the pan for 7 minutes. The temperature of the oil increases to 20 to 180. The density is given, the specific heat capacity is also given. Calculate the mass. Now, since density, which stands for rho, is mass divided by volume, so mass would be your density 910 into your volume, which is 0.0024. 910 into 0.0024 is basically 2.184, which is 2.2 kg. Then it says calculate the energy required to increase the temperature of the oil. Again, we just use the formula that we've written up here. Q is equals to mc delta T. So the mass I have is basically 2.184 in the specific heat capacity of 2000. Change in temperature, however, is from 180 minus 20. So into 2000 into 180 minus 20, which is 698880, which is basically 70, or you can say 698. So that would be, hold on, 7.0 into 10 to the power of 5 joules. Alright, so 7.0 into 10 to the power of 5 joules. Or you can also say, or, I'm just putting two options, 700,000 joules. It says that calculate the power required to increase the energy supply. Now, since energy is equals to power into time, time is given. So power would be the energy, which is 698,880, divided by the time. The time is 7 minutes. Always remember the time has to be taken in seconds. So 7 minutes into 60, which should give you the seconds value. Divided by 7 into 60, which is 1664, which is, let's say, 1700 watts. Two significant figures. Moving on, it says that, so here we are given some applications in the region of electromagnetic spectrum which should apply to them. You can use it once, more than once, or you can also use not oil. So this is a new topic, and you should always learn these properties well because they haven't been asked in 183 papers, I believe. So yeah, Bluetooth radio connection, you use radio waves. Why do you use them? Because they can penetrate through walls and only require a short aerial for transmission and reception. However, they are weakened by passing through walls. Optical fibers, infrared, because they can undergo, total internal reflection, which is important in optical fibers. Then security marking, you use ultraviolet. Why do you use this? Because it glows in the fluorescence lighting. Sterilizing food, gamma rays. Now, why is this? Because gamma rays have extremely low wavelengths and very high frequencies, which allows them to kill bacteria, and they can also have a high penetration power, which means that you can, basically sterilize all of the food without having to remove the packaging. Wireless internet uses microwaves because they're reflected from the Earth's atmosphere, and also they can penetrate the Earth's atmosphere. They cannot reflect, they can penetrate the Earth's atmosphere, which allows them to reach the international satellites which are, above the atmosphere, and hence communicate with them. So yeah, radio waves, infrared, ultraviolet, gamma rays, and microwaves. Instead, the approximate speed of radio waves in air, simple value 3.0 10 to the power 8. Just learn this value because it really helps you. Then it says figure 5.1 shows successive crests of a wave after the plane of partial gap. Draw 3 successive crests before. Now, most of the time, this question comes that before is given and after is given, but here they've changed it. It's a simple thing. What you do is, first you take your ruler and you draw a perpendicular line passing approximately through the state, because this is the line that you would use to, guide your lines. You will calculate the wavelength, which is, I believe here, 1.4 centimeters. Let me just check. It just has to be very by eye, so 1.4 centimeters. Then I would need to basically mark the center of this. The center of this would be, let's say, 1.4 as well, so not there. Okay, this is a bit difficult on the device, but yeah, I bet you guys can do it. 1.4, yeah. Then you would have, okay, now from 1.4 I would need 0, and then negative 1.4. Why is this not working? Yeah, alright, so did I mess up here? Just hold on, guys. So yeah, first things first, you calculate the distance, which is why did I zoom in here? I see it this way, it's better. Yeah, now you can see it's 1 centimeter exact, so I would just put it here also, -1, -2, and -3. The wavelength has to be basically in the diagrams, theoretically it has to be accurate, but since we cannot draw the most accurate, we just have to be close to eye. So it should, by eye you should look that it's, you have tried to maximize your efforts into it, although it does not have to be accurate to 0.1, let's say. And they have to be parallel because after diffraction, they're basically going to split up like that. Alright, so I guess yeah, this diagram works. Then it says that figure 5.2 shows a much wider gap, and the same wavelength wave is used, but now the gap is much wider. So what happens is basically they're only asking us for 3 successive crests. I would just draw a line here. What is important to remember is that you would have the same lines. So let's say at a distance of again 1 centimeters, which is not important. Just make sure it's by eye. So I would just keep it 1, 2, and then 3. Why is this not marking here? 1, 2, and 3. So when I use this, I'm gonna have this straight lines with the next one being bigger, yeah, and then this one. Now you can think of them as like this, or you can just mark slightly curved edges, something like this. Just to make the effect of diffraction. Alright, moving on to the next question now. Moving up, we have question number 6, which is that figure 6.1 shows a full-scale diagram of an object O and an image per eye produced by a converging lens. The lens and its position on the principal axis are not shown. On figure 6.1, draw a single ray to locate the position of the center of the converging lens. So this type of question has actually been repeated, and it was asked very previously, but the only difference was the last time you had a graph chart or the graph paper on the back. This time I think it should be simpler without the graph paper, or it might be more complex, you never know. Basically the only difficulty likely to face here is the difficulty in judging the tip, which as you can see I'm also facing, and this would be worse in the paper since the printed is never better than the online version of it you see. This is the best I can get. Alright, and then you have a draw a single line to represent the position of the lens. Basically the lens is here. When it passes through this axis, the lens should be there. So if I get the exact point, it should be somewhere here. It says that label this as L. Label this as L. Alright. Now moving on, we have next, which says that calculate determine the focal length by drawing another ray. So to determine the focal length, all you gotta do is you got to have this arrow which goes straight 90 degrees from the tip. Now here you can see that it's not very accurate, but I'm just going to try my best. Okay, it goes here, and then from here it actually goes down all the way to here, to the same point where the other one reaches. Nope, that's gonna be a bit up, my bad. Yeah, this should be fine. Alright, and then you gotta measure the distance between these both. Which I believe is 2.1 centimeters. There should be like a range of these answers. Okay, now it says the object is moved 2 centimeter closer to the lens. State 2 changes to the characteristics of the image. Now what is the current distance between the object and the lens? It's basically about 2.9 centimeters. If you move it close, then it would be like closer to the lens than the principal focus. Now this is basically, remember the properties of a magnifying glass, in which your image is upright, enlarged, and it's a virtual image. So now the image would be a virtual image. We can't say enlarged because even in this diagram the image is actually enlarged, and it would be upright. When we inverted, and it would be a virtual image having a real image. Moving on, we also draw a symbol for a potential divider, which is simple. You just have it this way. I'm actually surprised by seeing this question that draw the symbol for a potential divider. Now, figure 7.1 shows a circuit. You have a power supply with 6 volts and then you have, this is the thing of battery, and then you have the V out, V in. So you are given two resistors. Find the value of V out when the resistor value is 3 kilo, yeah, here 3000 ohms. Now what is basically the concept is that this voltage will be shared in proportion to the resistances. So the one which has a larger one will get the more of the voltage, and one smaller one. So the formula is that V out over VR is equals to the R out. The R out basically means this one, R out over the total R. So in order to get V out, you would need to do is you would need to know the VR, which is basically the 6 volts, into the voltage, which is 1.0 basically 1000 over the total, which is 3000 plus 1000 into 4000. So that would be this way: 6 into 1000 ohms divided by 4. Effectively, with this, if we just say it's basically a comparison ratio. So I have the total is 6, and I need to divide it in the ratio 1:3. The total parts of 4, you divide 6000 into 4 parts and give 1 part to this and 3 part to the other one, which is 1.5. So V out is 1.5 volts. The value of R is adjusted until the current flow circuit is 1.7 milli, which is 10 to the power of negative 3. Calculate the charge that flows through the circuit in 300 seconds. Now this is easy. Q is equals to IT. If I know my 1.7 into 10 to the power of negative 3 into 300 seconds, that would give me 1.7 into 10 to the power of negative 3 into 300 seconds is 0.51 coulombs. Moving on to the next question now. Alright guys, so now we're moving on to the next question, which is question number 8, which says that figure 8.1 shows a wire carrying a large current. Figure 8.2 shows a square view from above. On figure 8.2, draw 3 magnetic field and indicate the direction of magnetic field and how its strength varies. So basically for this, you would have to use your right hand grip rule, or right hand thumb rule actually, which will point downwards. So when you point it downwards, you see that your fingers go in a clockwise direction. And always remember that in this type of, like when a single wire is passing, there are concentric circles. So when I say concentric circles, I basically mean circles. I can't draw them perfectly here. So the one circle is here, and the circle would be here, let's say. Now I know that they are not circles, but yeah, I can't draw them perfectly on this device. And then another circle. So the meaning of concentration is that the distance between the center and the first one, and the distance between the first one and the second one, as you move away, this distance should increase. What is this indicating? As you move away from the wire, the strength of the magnetic field is decreasing. And clockwise direction, so something like this. Please use a compass to draw the circles, or an object, that works. It says that the current in the wire increases when the direction of the current is reversed. State how these changes affect the magnetic field. So when you increase your current, the strength of the magnetic field will increase. So strength of magnetic field increases after you have actually increased your strength of magnetic field. Since the direction is reversed, the direction will also reverse. You can just simply just point your thumb upwards, and you would see that they're rotating in an anti-clockwise manner. So direction reverses. Alright, the next question is, electricity is transmitted at high voltage. Explain why a high voltage increases the efficiency of transmission even in thinner wires. Now here there's an important formula to be used, which is that power loss in any wire is given by the equation I squared R. The basic concept to understand it, to transmit this, since power is equals to current into voltage, if you want to transmit the same power, you can use a lower current and you can use a higher voltage. Now what this would do is that when you use a lower current, the temperature, the heating up of the wire is less. So and less energy is lost over, what you call your thermal energy, which means that you have more efficient transmission. And when you use thinner wires, again the surface area is very low, like the thickness of the wire is very low, which means the resistance is large. So when you use this method, you would try to get the most efficient possible. So to say that since power is equals to IV, the same power can be transmitted. The same power can be transmitted by using lower current, and higher voltage and higher lower current and higher lower current and higher voltage, which will reduce thermal energy loss. Now, why does higher current basically, in talk about thinner wires, why do they have higher resistance? Because the electrons which are carrying the electricity have to collide with the volts more frequently, and the particles are very close together, which actually creates high resistance. So thinner wires usually have high resistance. So which reduces thermal energy loss. This is important for thinner wires which have high resistance. So when you have high resistance, you don't want to have a high current, because that would basically increase the temperature a lot more. Then having a the point I'm trying to make is that if you have a wire with a very high resistance, then the current loss, if your current is very high, then the energy loss would be way greater than your voltage is high. This is very important for thinner wires which have high resistances. I hope this question is clear. If you have any doubts in any of these questions, please do comment down below and I'll try to get back as soon as possible. Then it says that an experiment detects alpha particles at a very thin sheet of gold foil, which is a popular experiment. Most of the alpha particles pass through the thin foils. What conclusion can be observed from this? It's a very basic conclusion that most of the atom is empty space. Most of the atom is empty space. Then it says that some of the alpha particles are deflected through angles less than 90 and a few are deflected through 180 degrees. Few are deflected through 180 degrees. State and explain two conclusions that can be drawn. So now there are a lot of conclusions that you can draw from this, mainly three conclusions, which are the nucleus is very small, because if the nucleus is very small, then very few particles which pass close to the nucleus, and there's some of the particles. Alright, that's one conclusion it's saying. Second thing, you say that the nucleus is positively charged, hence it repels the positively charged alpha particles, and hence there's a repulsive force which causes them to deflect. And you can also say that the mass of the gold nucleus is much more greater than the mass of the alpha particle, which means that large repulsive forces give it large deflections. Forces between your alpha particle and nucleus is large to give large deflections. So I would just keep the 2 points here, which are the nucleus is very small. The nucleus in this is very small. And the other point is that the nucleus is basically positively charged. Nucleus is very small and nucleus is positively charged. What can I derive from the term that nucleus is very small? That is that not many alpha particles actually pass close to the nucleus. Not many alpha particles pass close to the nucleus. Nucleus is positively charged, which suggests that alpha particles are positively charged, and then there's a repulsive force. Alpha particles are positively charged, hence repelled by the nucleus. Hence, there's a repulsive force. There is a repulsive force. I'll just break it down again. The conclusion that you have gotten, that first conclusion is the most atom is empty space because the particles just went straight through. Some of them are deflected, which suggests that the nucleus is very small. The particles which pass close together, many of them went straight away, but some of them which are close together were basically deflected at less than angle 90 degrees. Not many particles actually went through it. And you also the nucleus is positively charged, so and the alpha particles also positively charged, which cause them to repel. Now, so the source contain a radioactive isotope of strontium. The isotope decays by an emission of beta particles. The half-life this is 29 years. Shade the chain that which occurs when the beta particles in the nucleus. The nucleus, what happens is that a neutron changes to a proton. Now, originally, what happens in a beta emission is that a neutron changes into a proton and an electron. But since also only in the nucleus, the electron is then emitted out. So neutron is basically, I would say that replaced, or you can also changes replaced or changes to proton. Don't say electrons because only asking in the nucleus. Then it says the initial mass is 25 and calculate the mass after 87 years with the half-life is 29. So 87 divided by 29, which means 3 half-lives. If you divide the mass of that decays, mass of the isotope that decays, alright. So first of all, you would have 25 divided by 2, which is 25 divided by 2. Okay, 25 divided by 2, that is 12.5. 12.5 divided by 2 is basically 6.25, and 6.25 divided by 2 would be 3.125. Now you have got this mass, this is the mass, but this is the mass which actually remains. So how would we yeah, so this is the mass that has actually remained after this. So how would we know what is the mass that has been decayed? Would be basically after 87 years this much mass would remain, 3.125. So how much has been decayed? 25 minus 3.125, 25 minus 3.125, which is 21.875. 22. For those of you who are confused again, when you do this half-life equation, the final mass that you're getting is basically the mass that remains. Here the question is mass that has decayed. So compared to the original and compared to the final, how much you have, the difference would be the decayed one. I hope that's clear. Then a space physics question. So figure 10.1 shows different positions of A2S around the Earth. State a position of the moon where observers sees a quarter moon. A quarter moon is always like this. So basically this is your new moon, and then this A position or E position both show quarter moon. So you could say A or E or just one of them, so it's one mark, I guess. When there's a full moon is here, G. State the approximate time for the moon to orbit the Earth. So it says approximate, and approximate, you don't have to worry about having an exact answer. You could say a month, or let's say 29 days. I think 30 days will also be fine. Just say a month or 29 days. This is the best option. The average distance of the Earth from the Sun is 1.5 into 10 to the power of 8 kilometers. Calculate the orbital speed. Now the orbital speed, or you can also say V, is equals to 2 into pi into orbital radius divided by your orbital period. Or if you want in this form, V is equals to 2 pi r over t. So 2 into pi into radius, which is 1.5 into 10 to the power of 8, divided by the time, which is in 365 days, and you can just take 24 since are in kilometers. So 2 pi into 1.5 into 10 to the power of 8 divided by 365 into 24, which gives me 110,000. This is basically two significant figures, kilometers per hour. 110,000 kilometers per hour. Yep, 107. I'm just writing this value just in case you guys want to check your answers. 7, 8 dot. That is 110,000. The speed of the light is given. Calculate the time taken for the light to reach the sun. Now, important, meters per second, kilometers per hour, so just convert it. So when we have V is equals to your S is basically distance displacement divided by T. So the T would be the S, which is 1.5 into 10 to the power of 8 into 1,000. That would give you answer in meters, divided by the V, which is 3.0 into 10 to the power of 8. 1.5 1000 divided by 3.0 to the power of 8, which is 500 seconds. And by doing this question, we have reached. Now we move on to the last question, which is again regarding space physics. Question number 11. State the condition required for a protostar to become a stable star. Now, the process or the condition that is required is either inward attraction of the star. She is balanced by an outward force due to the high temperature center of the star. So that's what is right here. Inward force due to gravitational attraction. Inward force due to gravitational attraction should be balanced by outward force due to high temperature in center of the star. Due to high temperature in the center of the star. Then next question says define Hubble's constant. Hubble's constant is basically a ratio of the speed of recession. We can say of an object, it's not necessary. Recession of an object to its distance from the earth. To its distance from the observer, since we've not mentioned anything specifically about earth. Distance from the observer. Next up, we say that the current estimate for the Hubble's constant is given. State the equation which gives an estimate for the age of the universe. Now, the Hubble's constant is just speeded with the axis from the over the distance from the Earth, right? So this is a ratio. So if you want to give now, always remember that a speed v is equals to your distance divided by time. All right. If you want to find the time for something, we have s, that means the distance that has been moving over this speed, which can again be rearranged as 1 over h0, because the Hubble's constant is just that. So the time is equals to basically s over v, which does not get written, is equals to 1 over h Hubble's constant. Alright, I hope this is clear. So this is basically the equation that you need to remember for this. That is, the Hubble's constant is the speed at which, that is v over t. I'm sorry, here. The speed at which, if you set Hubble's constant h0, the speed at which the is moving over the distance from the Earth. If you rearrange this, that is your distance divided by your speed, you would get your time. That is 1 over h0. Calculate an estimate for the age of the universe. So this is just using this equation. So 1 over 2.2 into 10 to the power of negative 18. This would give an answer in seconds, which has been asked. So that makes it very easy. 2.2 into 10 to the power of negative 18, which is 4.5 4.5 into 10 to the power of 17 seconds. 4.5 into 10 to the power of 17 seconds. Alright, so this is the end of the video. I hope this video was very helpful for you guys. And if you have any doubts or if you have any reviews, any suggestions for the new videos, please do comment down below. Don't forget to like, share, and subscribe to the channel for more exciting and upcoming videos. See you then. Bye.